A mountain is a large landform that stretches above the surrounding land in a limited area, usually in the form of a peak. A mountain is generally steeper than a hill. Mountains are formed through tectonic forces or volcanism. These forces can locally raise the surface of the Earth. Mountains erode slowly through the action of rivers, weather conditions, and glaciers. A few mountains are isolated summits, but most occur in huge mountain ranges. High elevations on mountains produce colder climates than at sea level. These colder climates strongly affect the ecosystem of mountains. Different elevations have different plants and animals. Because of the less hospitable terrain and climate, mountains tend to be used less for agriculture and more for resource extraction and recreation, such as mountain climbing. The highest mountain on Earth is Mount Everest in the Himalayas of Asia, whose summit is 8,849.868 am above mean sea level. The highest known mountain on any planet in the solar system is Olympus Mons on Mars at 21,171 am. Definition. There is no universally accepted definition of a mountain. Elevation, volume, relief, steepness, spacing and continuity have been used as criteria for defining a mountain. In the Oxford English Dictionary, a mountain is defined as a natural elevation of the Earth's surface rising more or less abruptly from the surrounding level and attaining an altitude which, relatively to the adjacent elevation, is impressive or notable. Whether a landform is called a mountain may depend on local usage. The highest point in San Francisco, California, is called Mount Davidson, notwithstanding its height of 300 am, which makes it 20 feet short of the minimum for a mountain by American designations. Similarly, Mount Scott outside Lawton, Oklahoma is only 251 am from its base to its highest point. Witto's Dictionary of Physical Geography states some authorities regard eminences above 600 am as mountains, those below being referred to as hills. In the United Kingdom and the Irish Republic, a mountain is usually defined as any summit at least 2,000 feet high, whilst the official United Kingdom government's definition of a mountain, for the purposes of access, is a summit of 600 meters or higher. In addition, some definitions also include a topographical prominence requirement, typically 100 or 500 feet. For a while, the U.S. defined a mountain as being 1,000 feet or taller. Any similar landform lower than this height was considered a hill. However, today, the United States Geological Survey concludes that these terms do not have technical definitions in the U.S. The Union Environmental Programme's definition of mountainous environment includes any of the following: elevation of at least 2,500 am. Elevation of at least 1,500 am, with a slope greater than 2 degrees. Elevation of at least 1,000 am, with a slope greater than 5 degrees. Elevation of at least 300 am, with a 300 am elevation range within 7 km. Using these definitions, mountains cover 33% of Eurasia, 19% of South America, 24% of North America, and 14% of Africa. As a whole, 24% of the Earth's land mass is mountainous. Geology. There are three main types of mountains: volcanic, fold, and block. All three types are formed from plate tectonics, when portions of the Earth's crust move, crumple, and dive. Compressional forces, isostatic uplift and intrusion of igneous matter forces surface rock upward, creating a landform higher than the surrounding features. The height of the feature makes it either a hill or, if higher and steeper, a mountain. Major mountains tend to occur in long linear arcs, indicating tectonic plate boundaries and activity. Volcanoes. Volcanoes are formed when a plate is pushed below another plate, or at a mid-ocean ridge or hotspot. At a depth of around 100 km, melting occurs in rock above the slab, and forms magma that reaches the surface. When the magma reaches the surface, it often builds a volcanic mountain, such as a shield volcano or a stratovolcano. Examples of volcanoes include Mount Fuji in Japan and Mount Pinatubo in the Philippines. The magma does not have to reach the surface in order to create a mountain. Magma that solidifies below ground can still form dome mountains, such as Navajo Mountain in the United States. Fold mountains. Fold mountains occur when two plates collide, shortening occurs along thrust faults and the crust is over-thickened. Since the less dense continental crust floats on the denser mantle rocks beneath, the weight of any crustal material forced upward to form hills, plateaus or mountains must be balanced by the buoyancy force of a much greater volume forced downward into the mantle. Thus the continental crust is normally much thicker under mountains, compared to lower-lying areas. Rock can fold either symmetrically or asymmetrically. The upfolds are anticlines and the downfolds are synclines. In asymmetric folding there may also be recumbent and overturned folds. The Jura Mountains are an example of fold mountains. Block mountains. Block mountains are caused by faults in the crust, a seam where rocks can move past each other. When rocks on one side of a fault rise relative to the other, it can form a mountain. The uplifted blocks are block mountains or horsts. The intervening dropped blocks are termed graben. These can be small or form extensive rift valley systems. This form of landscape can be seen in East Africa, the Vosges, the Basin and Range province of western North America and the Rhine Valley. These areas often occur when the regional stress is extensional and the crust is thinned. Erosion. During and following uplift, mountains are subjected to the agents of erosion which gradually wear the uplifted area down. Erosion causes the surface of mountains to be younger than the rocks that form the mountains themselves. Glacial processes produce characteristic landforms, such as pyramidal peaks, knife-edge arêtes, and bowl-shaped cirques that can contain lakes. Plateau mountains, such as the Catskills, are formed from the erosion of an uplifted plateau. Climate. Climate on mountains become colder at high elevations, due to the way that the sun heats the surface of the earth. The sun warms the ground directly, while the greenhouse effect acts as a blanket, reflecting heat back towards the earth that would otherwise be lost to space. The greenhouse effect thus keeps the air at low elevations warm. As elevation increases, there is less greenhouse effect, so the ambient temperature goes down. The rate at which the temperature drops with elevation, called the environmental lapse rate, is not constant, but a typical lapse rate is 5.5 degrees Celsius per 1000 am. Therefore, moving up 100 meters on a mountain is roughly equivalent to moving 80 kilometers towards the nearest pole. This relationship is only approximate, however, since local factors such as proximity to oceans can drastically modify the climate. As the altitude increases, the main form of precipitation becomes snow and the winds increase. The effect of the climate on the ecology at an elevation can be largely captured through a combination of amount of precipitation, and the biotemperature, as described by Leslie Holdridge in 1947. Biotemperature is the mean temperature, where all temperatures below 0 degrees Celsius are considered to be 0 degrees Celsius. When the temperature is below 0 degrees Celsius, plants are dormant, so the exact temperature is unimportant. The peaks of mountains with permanent snow can have a biotemperature below 1.5 degrees Celsius. Ecology. The colder climate on mountains affects the plants and animals residing on mountains. A particular set of plants and animals tend to be adapted to a relatively narrow range of climate. Thus, ecosystems tend to lie along elevation bands of roughly constant climate. This is called altitudinal zonation. In regions with dry climates, the tendency of mountains to have higher precipitation as well as lower temperatures also provides for varying conditions, which enhances zonation. Some plants and animals found in altitudinal zones tend to become isolated since the conditions above and below a particular zone will be inhospitable and thus constrain their movements or dispersal. These isolated ecological systems are known as sky islands. Altitudinal zones tend to follow a typical pattern. At the highest elevations, trees cannot grow, and whatever life may be present will be of the alpine type, resembling tundra. Just below the tree line, one may find subalpine forests of needle-leaf trees, which can withstand cold, dry conditions. Below that, montane forests grow. In the temperate portions of the Earth, those forests tend to be needle-leaf trees, while in the tropics, they can be broadleaf trees growing in a rainforest. In society, Mountains are generally less preferable for human habitation than lowlands, because of harsh weather and little level ground suitable for agriculture. While 7% of the land area of Earth is above 2,500 meters, only 140 million people live above that altitude and only 20 to 30 million people above 3,000 meters elevation. The decreasing atmospheric pressure with increasing elevation means that less oxygen is available for breathing, and there is less protection against solar radiation. Due to decreasing oxygen, the highest known permanent habitation in the world is at 5,100 meters, while the highest known permanently tolerable altitude is at 5,950 meters. Above 8,000 meters elevation, there is not enough oxygen to support human life. This is known as the death zone. The summits of Mount Everest and K2 are in the death zone. About half of mountain dwellers live in the Andes, Central Asia, and Africa. Traditional mountain societies rely on agriculture, with higher risk of crop failure than at lower elevations. Minerals often occur in mountains, with mining being an important component of the economics of some montane societies. More recently, tourism supports mountain communities, with some intensive development around attractions such as national parks or ski resorts. About 80% of mountain people live below the poverty line. Most of the world's rivers are fed from mountain sources, with snow acting as a storage mechanism for downstream users. More than half of humanity depends on mountains for water. Mountaineering, mountain climbing, or alpinism is the sport, hobby or profession of hiking, skiing, and climbing mountains. While mountaineering began as attempts to reach the highest point of unclimbed big mountains, it has branched into specializations that address different aspects of the mountain and consists of 3 areas: rockcraft, snowcraft and skiing, depending on whether the route chosen is over rock, snow or ice. All require experience, athletic ability, and technical knowledge to maintain safety. Superlatives. Heights of mountains are typically measured above sea level. Using this metric, Mount Everest is the highest mountain on Earth, at 8,848 meters. There are at least 100 mountains with heights of over 7,200 meters above sea level, all of which are located in Central and Southern Asia. The highest mountains above sea level are generally not the highest above the surrounding terrain. There is no precise definition of surrounding base, but Mount McKinley, Mount Kilimanjaro and Nanga Parbat are possible candidates for the tallest mountain on land by this measure. The bases of mountain islands are below sea level, and given this consideration Mauna Kea above sea level, is the world's tallest mountain and volcano, rising about 10,203 am from the Pacific Ocean floor. The highest mountains are not generally the most voluminous. Mauna Loa is the largest mountain on Earth in terms of base area and volume. Mount Kilimanjaro is the largest non-shield volcano in terms of both base area and volume. Mount Logan is the largest non-volcanic mountain in base area. The highest mountains above sea level are also not those with peaks furthest from the center of the Earth, because the figure of the Earth is not spherical. Sea level closer to the equator is several miles farther from the center of the Earth. The summit of Chimborazo, Ecuador's tallest mountain, is usually considered to be the farthest point from the Earth's center, although the southern summit of Peru's tallest mountain, Hasarien, is another contender. Both have elevations above sea level more than 2 kilometers less than that of Everest. See also, Latin names of mountains, list of mountain ranges, list of peaks by prominence, list of ski areas and resorts, lists of mountains, mountain hut, notes. References. External links, media related to mountains at Wikimedia Commons, quotations related to mountains at Wikiquote.